Question number 3. This question is about different forms of carbon. Figure 5 represents the structure of diamond. Now you need to remind yourself of different forms of carbon. At this stage, you need to know about 4 different forms of carbon, namely diamond, graphite, nanotubes, and we have fillet rings. So these are the 4 different forms of carbon. It says describe the structure and bonding of a diamond. So there are 2 key words, structure and bonding. So our answer must revolve around these 2 key words. When it comes to the structure, we know that carbon is one. When it comes to structure, we know that diamond is one of the giant covalent structures. I can say it is giant covalent structure. Number 2, I also know that it is called giant covalent structure because covalent bonds are in all directions. So we can say covalent bonds are in all directions. It's a 3-mark question, so I'll have to add one more statement to get 3 marks. If I look at this carbon atom, I can see there are some covalent bonds around it, and they're being represented by these lines. You can see here there's 1, 2, 3, and 4. Now we can look at this carbon atom. Again, there are 4 bonds around it. If I look at this carbon atom, there are 4 bonds around it. If I look at this carbon atom, there are 4 bonds around it. So I can say each carbon atom has 4 covalent bonds. And this will get us 3 marks in this question. Next part, it says explain why diamond has very high melting point. Remind yourself, melting point, it's a physical property. If it is a physical property, it will depend on breaking bonds. In this case, you'll have to say covalent bonds require breaking. Number 2, I know covalent bonds are strong. If they are strong, this means it requires a lot of energy. Therefore, MP is high. Next part says figure 6 shows the molecule C70. Now let's quickly have a look at this word molecule C70. This means each molecule has 70 carbon atoms. So I can say one molecule is basically equal to 70 atoms of carbon. It says what's the name of this type of molecule? So they've given you the 4 options here: fullerenes, graphene, nanotube, or polymer. In this case, the answer is fullerene. Next part says molecules such as C70 can be used in medicine to move drugs around the body. Move drugs around the body. So this means they will become part of your body because you have to take them in. Suggest one reason why C70 molecule is suitable for this use. Now anything that has to enter in our body must not be toxic. The first thing that we can think about is that we can say it is non-toxic. Number 2, you also need to remember one thing more here, that anything that goes in our body has to be unreactive. So we can also say it is unreactive. Option number 3 that we can discuss here is, if you go back to the diagram here of C70, you can see it's a hollow molecule. So if it is a hollow molecule, then it can be used to carry drugs. We can say hollow molecule. Last part of this question says calculate the number of C70 molecules that can be made from 1 mole of carbon atoms. From 1 mole of carbon atoms. And they've given you some values here that the Avogadro constant is 6.02 times 10 to the power of 23 per mole. Now, this statement is of importance here because it says 1 mole of carbon atom means there are 6.02 times 10 to the power of 23 atoms. And this is equal to 1 mole. Now, we need to make molecules out of it. And we know that each molecule has 70 carbon atoms. So all I'll do is I'll divide this by 70. We'll end up with a value which is 8.6 times 10 to the power of 21 molecule.